Hello everyone and welcome back. I am Mr. Kobold, and in this video we're going to go over the second problem where we are going to use stoichiometry and the ideal gas law. So once again we have a balanced equation, and we're going to use that balanced equation to convert from one substance to another substance depending on what they're asking for. So remember, the key to solving word problems is you're just going to pull out the information. You're looking for things that are relationships, because the relationships are going to be conversion factors. And you're going to, in this case, we're going to be using the ideal gas law, so you're also going to use that equation. But we're looking for conversion factors. The other thing you're looking for is where to begin your problem and where to end. And again, 99% of the time, that is in the question. So here we have our balanced equation. They're telling us that 4.58 liters of oxygen forms at, and then they give us the pressure at 745 millimeters of mercury and a temperature of 308 Kelvin. Okay, so they're giving us the conditions for gases. Or we're going to use this for the ideal gas law. So here's the question. Remember what I said at the beginning of the question always gives you the end of the problem. So how many grams of silver oxide decomposed? So notice I said silver oxide. It's not silver 1 oxide, because silver only has one charge, so we don't need a Roman numeral. So silver oxide decomposed. So they want to know how many grams. So we're going to go to a number of grams of silver oxide. Okay, so where are we going to have to start? We're going to have to start at any given information. Now, the pressure and the temperature, that's not going to be useful to us for conversions, but that will be useful to us for the ideal gas law. The only other information they give us is the liters, the volume of oxygen formed. So that's where we have to start. So we're going to start at the 4.58 liters of oxygen gas, and we're going to get to grams of the silver oxide that decomposed. So here's where we're going to start. So we have 4.58 liters of oxygen. We're going to put that over 1. Okay. So oxygen is a gas, actually. So we can use the liters of the gas to combine with the pressure and the temperature to convert to moles. So that's going to be important. So we have liters of gas. So we're going to use our ideal gas law. So if we can convert to moles using the ideal gas law, then we can use the mole to mole ratio in our balanced equation. So we're going to solve for moles. So that's going to be, so we have PV equals nRT. So solving for moles, it would be PV over RT. And number of moles is equal to PV over RT. So remember what I said before, that pressure has to be in atmospheres, temperature has to be in Kelvin. So temperature is good. We need to convert pressure to atmospheres. So we're going to take the 745 millimeters of mercury over 1. We're going to multiply by the conversion factor. So 760 millimeters of mercury under 1 atmosphere. So millimeters of mercury cancel out, we have atmospheres. So if I do that calculation, then what I get is 745 divided by 760 equals Okay, and that gives me 0.980263 atmospheres. Okay, once again, this is exact relationship, so we don't have to worry about sig figs here. So we have 3 sig figs. So our answer should have 3 sig figs. 1, 2, 3. Underline the 0. I can keep the 2 or more to avoid rounding mistakes. So now I have the atmospheres. I can plug everything into this equation. So pressure is going to be 0.9802. I'll just leave it as a 2, or I can, I'll just leave it as a 2. That'll be atmospheres, and then I have volume. So the volume was 4.58 liters. 4.58 liters over R, which is 0.08206 liter atmospheres over mole Kelvin. And then I have temperature, which is 308 Kelvin. So Kelvin cancels out. Moles does not cancel out. Liters cancels out. Atmospheres cancels out. And so we're left with moles, which is what we want. And so we calculate that once again. So, multiply this times 4.58 divided by 0.08206 divided by 308 equals. And there I get the number of moles is equal to 0.1776, 1776, the year that the nation was born. Okay, so let's throw 339 in there. This is going to be moles of oxygen. Okay, so we have the moles of oxygen. So now we can use our mole ratio to go from moles of oxygen to moles of the silver oxide, which is what we want. So we take 0.1. Oh, by the way, we should figure out the number of sig figs. So we have 3, that's a measure. This is 4, we don't have to worry about that. This is 3, and this is 4. So the least number is 3, so cut it off there. So we'll keep one extra digit, 0.1776 moles of oxygen over 1. Okay. The mole ratio between oxygen and silver oxide is 1:2. So 1 mole of oxygen to 2 moles of silver oxide. Moles cancel out. Now I have moles of silver oxide, but they're asking for grams. So I need the molar mass of silver 2 oxide. So I gotta look that up. So silver is, what is silver? Silver is 107.87. 107.87 times 2 equals plus, and then we have oxygen, which is going to be 16. So plus 16 equals, and that gives us 231.75. 231.74. So 231.74. So it's 231.74 grams of the silver oxide on the top. 1 mole of the silver oxide. Oops, I forgot the 2. On the bottom, moles of the silver oxide cancel out. And now I have grams, which is what I want. So now I know I can stop with the conversion factors. And now I'm going to just multiply and divide the answers that I have. Okay, so I have 0.1776 times 2 times 231.74 equals, and I get 82.314 grams of the silver oxide. Now, I have to decide how many sig figs to keep. So, coming back to what I multiplied and divided, so the ones I can ignore, this I can ignore, that's exact. This is a measure, there's 5 sig figs here. And here I actually only have 3 because remember, the 7 is underlined, so that's my last sig fig. So I have 3 sig figs here, that's the least number. So I'm only allowed 3 sig figs. So the 3, that is what I would report. So 82.3 grams of silver oxide had to decompose to give me 4.58 liters of oxygen gas. I hope that was helpful and clear. If you like this video, please go ahead and like the video, hit the subscription bell on the bottom down here. Make a comment in the comment section and tell me what you think. Thanks for joining me. I hope you enjoyed it. See you next time.